picture is obviously not something that drew myself, but I found a very similar structure, similar architecture. Basically, what you see on the screen is a Pix-Hawk autopilot, which in my case is based on PX4 code. And everything on the kind of moving base is driven by that autopilot. But when it comes to programming that autopilot, for example, changing the path, changing the waypoints, it will be done by Jetson Nano in this case. And there will be some vision package that I have to still program. So that's the idea. And I'm making slow progress, mostly about compiling and attaching the sensors to my little head that is supposed to be positioned on top of the robot. Let me show you how it looks like. What you see on the screen is basically Jetson Nano with two eyes, two cameras, stereoscopic camera from WaveShare, and it will take its place in the head of the robot at some point, but at this point just on your screen as a reminder. I created a little custom Raspberry Pi head, and you can see my sloppy work here. It is basically to connect ADC, analog to digital converter here, which is MCP 3008. There is an I2C, I2C bus right here, and you can see the Raspberry Pi connector. There is a little schematics here that disconnects GPS from Raspberry Pi serial. Mm-hmm. It's a necessity because otherwise the booter will not boot the operating system. So you have to disable it until it's ready to start kind of operating in normal mode. Otherwise, GPS will send some garbage to the U-boot booter, and Raspberry Pi will not boot. So I had to take care of that portion of it. There is some more stuff by now on this custom head. I was posting in the email thread, I was posting the link to Amazon, site where you can buy those. And they seem to be very well made, they're convenient. So if you need a custom Raspberry Pi hat, it will be available. This is my, schematics of that same hat. So this is how the head of the robot looks like. You can see basically a toolbox that I picked up in the Home Depot for, I believe, $6. They had a sale on those. And I put NVIDIA Jetson Nano right here with the cameras looking forward. So the bottom of the toolbox is the forward-looking kind of face of the head. You can see RC receiver here. You can see Raspberry Pi with the custom head. You can see Raspberry Pi servo controller, which is connected through I2C. You can see that little extender here. You can see GPS right here. And you can see teensy RC kind of connecting controller that I programmed to take signal from PPM, which is combined channels from the RC receiver, process it here, and the channels become available through I²C. So basically, when Raspberry Pi wants to query the current state of the RC sticks, that's available for the autopilot to take into consideration. In manual mode, those signals will be going through RC receiver, through teensy, through I²C extender into Raspberry Pi, and the Raspberry Pi will, in manual mode, forward them to the server head. And the server head will be connected to those big servos that you saw, or to the motors of the other platform. And speaking of the other platform, you can see how, I mean, let me scroll through a couple of slides here, how the head is looking. So I have a fan here, I have NVIDIA. These are cameras, they are looking to the bottom of the box, which is face of the head. This is how it looks like from the front. So stereo cameras, the NVIDIA buttons, power and reset, and I have access to the SD card here. And there is a little neck here, and you can see that it is a robust kind of skull for the whole thinking, circuitry of the robot. Now, this is how it looks like on the debugging platform. So this two-wheeler, you saw it before going through the lawn very easily, so it's capable of, kind of not mowing the grass, but at least easily going through the grass. And there is a GPS, of course, on the top of the head, and I will be able to plan the waypoints and to plan the route through the waypoints. The interesting part about this platform is that you can see here the remainder of the previous robot. These sensors are actually coming from the car parking sensor. And you can see that display. So I have 4 corners, 1, 2, 3, 4, which carry those little ultrasonic sensors. They are all connected to the display that comes with them. So it's all tuned up, working assembly for the car parking. And then I connected through Arduino to basically USB. So I can have Arduino collecting the data, kind of running the 4 signals from the ultrasonic transducers into the Raspberry Pi, into autopilot, into the ROS. So that's how it will be working. And it's been working fine before, so it's just a matter of connecting that Arduino to the ROS. Okay, next slide. This is how it looks from behind. You can see that whole, assembly. This is GPS on top of the skull. You can see the Raspberry Pi HDMI connector right here. You can see the 880 U-Blocks GPS. And there is a little dome on top of it, I will show you on the camera how it looks like in live. So this is how it looks like, that dome when it is already mounted on top of GPS. This is the same NVIDIA assembly. It has its own Raspberry Pi head. This is how Raspberry Pi fits into the toolbox, into the skull. You can see there is a little bit of circuitry here, which is a distribution panel for 12 volts. The red connectors here are 12 volts, and the yellow connectors are 5 volts. So this is how I assembled that thing. This is RC and fan, RC receiver and fan. And yet again, NVIDIA with the stereo camera. And yet again, NVIDIA from a different perspective. And now I have a flat cable that goes inside the NVIDIA box. And the reason why I positioned that NVIDIA, case like this, in a kind of angled manner, is because of these short flat cables. Otherwise, I couldn't kind of nicely fit it in the box. So whatever, I had to do it. And there is a little OLED display here. There is a usual I2C distribution panel, I2C extender. There is obviously the OLED and I believe it is accelerometer here, or gyroscope that is connected to distribution, to the extender. So everything kind of will be operational at some point. I mean, obviously I ran the tests after connecting it, and the components work. That's yet another look at it, and you can see the little display showing the IP address of the Jetson Nano. So it's operational and happily working. This is IMU. I made that photo to remind myself how to connect it to the SPI connector of Raspberry Pi. Normally, when you buy this little thing, it is normal to connect it through I2C, but I2C is a slow interface. In Autopilot, this little thing works at 800 Hertz under Linux. So this is when the Kalman filters and everything else around that, accelerometer and gyroscope and compass can work efficiently and reliably at, in real time. So it requires about 1 kilohertz around that sampling rate. So I2C cannot do that, SPI can do that. So there is a little trick here, and you have to remove these two resistors from I2C, pull-up resistors. For whatever reason, every manufacturer puts them in their boards, which is a completely wrong thing to do. There should be only one pair of resistors on the I2 bus. So that's pretty much it about the hardware. And here you can see the ground station offering me an option with the lawnmower to calibrate my gyro and accelerometer. So guys, I definitely need at least 5 people to rotate my lawnmower while calibrating the sensors. Please come to Alabama, otherwise I won't be able to go through this little step here.
Build another 5 robots to help you.
It's one of those dark secrets of the IMUs and a big old robot. Yeah.
Well, I tried to put that, you know, head alone on tail, on the wing and stuff like that. It's quite a process. You can see the green color here, so I completed that little exercise, but it's kind of tricky. Anyway, that's all about the slides. Let me unshare the screen and show just, can you see what's happening?
Yes.
Yes. So currently it is kind of working right here. NVIDIA is out of the box. It's on the workbench somewhere. And there is only Raspberry Pi with the accelerometer 9D of IMU, GPS, another compass with GPS, ADC, and all that, you know, peripherals. And I have Raspberry Pi basically talking to the screen here and delivering my role and pitch and everything else. And keep in mind that all that data is available to ROS through Mavros bridge. So even as Autopilot is using it for its own kind of operation, and the ground station is using it for displaying, for example, in this case, where my robot is, and it is a little off here. There are, let me see if I can, yeah, it's off a lot. Anyway, the data, the same data that is available to the Autopilot and the ground station can be subscribed to from, in this case, ROS1, but I hope Mavros will be released into ROS2. It's in the works, and hopefully, you know, I will be able to use it in ROS2. That pretty much concludes my presentation. Do you have any questions, guys?
Yeah, I do.
Yeah, Jim, go ahead.
Or you do? You can go first.
Oh yeah, I was just going to say, because we've chatted a little bit about ROS1 versus ROS2. For your application, is there any specific features of ROS2 that you're looking forward to that make it worth the effort?
Well, not really. I mean, if I were reasonably, you know, proficient in ROS1, I would go with ROS1. But I am a complete beginner in ROS. I did some Turtlebot and navigation and stuff like that. I did some programming for the bridge to C# and stuff like that. So I'm kind of a little bit aware of where it is. I have forgotten everything by now. You know, it's been like 3 years. And if I have to start with it, the process will be slow. It will take half a year. By half a year, you know, from now, by Christmas, by New Year, there will be, you know, enough of ROS2 in operation that I will be, you know, kind of using it to a reasonable extent. That's my thinking at this point.
Yeah, I had a question. Which IMU are you using and which stereo camera?
Well, stereo camera comes from WaveShare.
WaveShare?
And I actually posted somewhere in the, it's sold from WaveShare directly, and you can buy it from that same WaveShare on eBay. And Waveshare sells a wonderful case, which I'm still enjoying for for Jetson Nano, and this camera. And my only concern about this camera is that it might be not aligned very well out of the box. But I have to align it in software, you know, kind of create all these matrices, and basically it's not a big deal. It's just, you know, things are like this.
And the IMU, is that?
IMU is just a standard 9265, which is actually 9250 / 6500. And
Okay.
on Amazon, they are wildly used, and they are really good. I mean, the stability of these gyroscopes is out of this world. You know, I mean, they are really good.
Yeah, because that's the one I have one of those that I tried to make that walking robot go straight, but I was only using the compass. But that's the one I never got the drift fixed, or I never I haven't done the exercise of compensating for the gyro drift, but that's pretty easy. I've heard.
You have to use motion library for Arduino, and it takes care of everything. Basically, you will have the 9 degrees of freedom IMU, not just, you know, a sensor, but the whole fused IMU.
Yeah, I had used some other one. The one I had was from a particular guy who's like does a lot of work with that 9250, and had sort of some code with a sensor fusion, and but I didn't get it to work that well. I mean, although I'm new to IMU, so
Change the guy.
Yeah, I mean, he's pretty well. Anyway,
the library is called Motion Plug.
Motion Blur.
Plug. PLUG. Plug.
Motion Plug.
Motion Plug.
Okay, maybe I might have been using the harder one. But
and it's as I say, you know, I've been using it for years. You know, that same board, I have bought a bunch of them, and they are very good. The other board that I keep, you know, kind of meeting on the internet with good good reviews is BM160. It comes from Bosch, or Bosch, whatever, that big automotive company. And the little thing was designed for automotive users and for wearables. So it is reasonably good in terms of, you know, serving as IMU.
Does the one you're using provide a compass heading, or just the 9 degrees?
I believe it is a full 9 degrees of freedom. So there is accelerometer 3, gyroscope 3, and compass magnetometer 3.
Yeah.
And usually, sometimes for quadrocopters, for example, you can buy 10 degrees of freedom, which basically is that same 9250 or 9265 actually chip, and it has I2C bus, which is separate from the, you know, computer connected I2C bus. But on that I2C bus, you can have barometer pressure sensor sitting and delivering that 10th degree of freedom, which is atmospheric pressure. And you can raise that sensor up and down like this with your hand, and you can see a graph going up and down from the barometer. That's the resolution, the sensitivity of this.
So your drone can hover.
Yep. I mean, you can hover vertically, but to hover horizontally, you have to have that little mouse device that is looking down with the camera, the optical drift, whatever it is. Yeah. Okay, sorry, I'm taking probably too much time.
This is great. I've got one. I've got another follow-up question because I've been dinking around with an IMU for Todd, and you had mentioned Kalman filters. Are you rolling your own sensor fusion for it, or have you been dabbling with like the RT-IMU Lib?
Well, in this particular project, the autopilot has a very sophisticated way of dealing with the sensors, you know, so it fuses them. I don't mess with them. All I'm taking care of is, you know, physical connection, electrical connection, and then, you know, kind of looking at the code and configuration files, and it just starts working. I had to reprogram the ADC, the analog to digital conversion, but it's 20 lines of code and a lot of copy pasting. But for the Arduino, that motion plug library takes care of some fusion. It's not very sophisticated. It is a Kalman filter, but it's not, you know, it runs on Arduino as far as I can tell. The beauty of those 9250 microchips is that it has a very powerful processor on board, and it is intended and designed to do that fusion. But to do that fusion, you have to download special code into that. So it's when you buy it from eBay, it is not programmed like this. And I don't know if it has been hacked already. I mean, I looked into it extensively 5 years ago or so, and it wasn't available for hobbyists. But this is the proper way to use that chip.
And when you talked about that solder modification to get the higher speed, is that well documented? I mean, that's to go from I squared C kind of, which maxes out at, I don't know what it maxes out at, like 100 or less than 100 hertz to get your 800 hertz.
Well, SPI has a clock rate from 1 megahertz to 20 megahertz. So the fastest SPI connection that you can have on the between the microprocessor and your device is 20 megahertz megabits basically per second, and that's, I believe, well beyond like 20 times faster than I squared C. And it's completely different protocol. I mean, it's completely different physically. It's completely different kind of on the protocol level, on the signal level. And on the board that you buy off the eBay, the pins are connected to those, you know, kind of, the pins are out for you to solder to. But you have to remove those two resistors because they are only for I squared C, and you have to enable a couple more pins which are already available on that side of the board. If you are really interested, I mean, I have done it. It took me about a day to research between the cucumber tractor and the other things. And basically, I mean, I'm more than willing to share. Ask me a question on the email thread, and I will send you all the information.
Okay. And one last question I had: how does the ROS component of this, is that running the ROS? You have a ROS client and server running on the Raspberry. Pi or a,
No, as for Raspberry Pi, I loaded it with Ubuntu 20.04, but not the desktop version, but the server version.
yeah.
So it is basically headless. It has login prompt on the HDMI, but I mean, you can use it as a dumb terminal, but no X Windows, no desktop, no nothing. What it gives me is a very clean installation of Ubuntu 20.04. The ROS, I believe ROS Melodic runs on it comes with Jetson Nano.
Oh, okay.
When you install Jetson Nano in some configuration, it does have Melodic on it.
Okay, so that, yeah, the Jetson has ROS, and it's doing publishing, I assume.
The problem for me is that Jetson Nano runs on Ubuntu 18,
Oh,
and I'm trying to stay current with Ubuntu. So, I mean, there is I mean, that's my philosophy, you know, I don't want to be on the backward release of anything, whatever, you know, because of, you know, many things. So, I mean, but with Jetson Nano, I don't think it is a problem, you know. I mean, obviously, the bridge is there, the Mavros bridge between autopilot and the ROS should be operational no matter which operating system is running on Jetson. So, yep.
right, but I guess my real interest is the ROS communication. It's between the Mavros and the Jetson. It sounds like, right? The subscribing and the publishing. Publishing is coming from the Jetson, and the Mavros is subscribing to topics.
Not necessarily. I mean, it's a two-way communication. For example, ROS can send a topic to autopilot. That's my understanding of it.
Either way, it says, yeah, it's a two-way, but those are the two components talking. The Mavros and the autopilot and the Jetson.
Right, and I'm not even close to that. You know, I mean, between the soldering and you know, mechanical things and programming that PH4 autopilot code, trying to understand kind of the whole code tree, where the drivers are, where the applications are. It is architecturally, it is very, very sophisticated, very well designed. It is ROS-like, kind of publish, subscribe. It is very real-time oriented, slow channels oriented. It has a lot of really good features that ROS even, you know, never dreamed of. So it's an interesting side of robotics, interesting dark corner of robotics that is definitely worth looking at.
Cool. Any other questions for Sergey?
Sergey, you mentioned about calibrating your gyro, and you talked about having to flip over your big robot. Isn't there a trick to do that unmounted and then later mounted once it's calibrated?
Well, the trick is a long enough cable to the IMU. It becomes a little tricky. You know, the problem is that IMU is, it does have its own compass. But the beta compass is coming with the GPS. And the GPS is positioned on top of, you saw the dome on top. I can point on it right here. It's positioned on top of the robot, so it's kind of magnetically isolated to some extent. And you have to rotate that whole head. And the connection between the head and the robot is just 12 volts cable. So it's not a big deal to take the head off, this whole skull off, and start rotating it like this in the middle of the field. So I don't see it as a problem. But if you want to help, come to Alabama, guys. I mean, it's wonderful here. Any more questions? Well, thank you very much.
Thank you.
I'll keep you
Thank
posted
you.
and ask me questions in the email thread. Thank you.
Sure.
Thank you,
Awesome.
Sergey. That was great.
Thank you.
Yeah. Now, next we have Mike wanted to do a 5 minutes for to show what he's working on. Which mic is that?
Yeah.
There we go.
Can you hear me?
Yep.
Okay. So I'm working on a small RC car. I think you can see that. Wait. And my computer monitor died. Well, anyway, here it is. Someone else better go because I need to fix my monitor.
Oh.
Sorry.
Well, he sets up. We have a couple of guests, or maybe even more here from the HBRC, the Homebrew Robotics. So we got Camp and Bob Allen there, and I remember seeing Camp many years ago with his little springy thingy robot. That's very famous. I mean, it's all over the
Springy
place.
thingy's my Burning Man robot.
Yeah, so that was
He's back here in the robot room.
excellent. That was a ton of years ago. And then Bob,
Couple years old.
I met Bob Allen in Robotica.
Oh, really?
Oh yeah. I
Okay.
had a iDroid. You probably don't remember, but yeah, I had iDroid and a couple other ones. But yeah,
That's
I met you.
almost 20 years ago.
2001.
2001.
But you
Wow,
know
what
what?
did that time do?
Here's the thing: you haven't changed at all. You look exactly the same. 20
Well, thank you. I
years
appreciate
ago.
it. Yeah, actually, Camp was with us too down in Robotic.
Really?
I went up, and I
What was
think
that?
his-
The Bumble? What did you have? The Bumblebee? What was your robot?
No, mine was.
that
It was
was,
called. Oh yeah, him. Yeah.
Go ahead, Walter.
I had
Go ahead.
iDroid. I had iDroid.
Yeah. Yeah, I had, well, let's see, I did two. I think that one wasn't Viper, it was
Viper.
something else, I think. But it was, but I went up against you, and the director on the figure eight told me, because it was like springy thingy.
You were taking it easy on the evil beaver.
Yeah, they told me to, go easy on him, because I had this steel 200-pound robot that we
Well,
could
the evil
easily take
beaver. The evil beaver had a power drill on the front and an electric chainsaw in the back.
Yeah, really.
So
was
yeah,
good
so
stuff.
that was that's amazing that you guys are here. That's such a long time
times.
ago. Yeah.
Well,
very
thanks
good.
for having me.
Yeah, thank you for coming.
I have to apologize. I thought the meeting started at 7.
Oh no.
Well, I thought it started at 3:45, so Camp, you and I are just getting too old.
Sorry,
Never.
I forgot to post. I will post
Never.
it next time.
It's all right. Better late than
Thank
never.
you. Thanks.
Better early than late.
Walter, what is that spaceship behind you? Are you using it daily or just?
That's my daily driver to work. I
That's the land speeder from
Land speeder,
Tatooine.
that's what it is.
that's a Disneyland. Just a photo I took last time I went there.
Yeah.
Yeah, I took the
Galaxy's
same.
Edge.
Yeah, they have this beautiful setup over there. If you guys ever get a chance to go.
Oh yeah, it's like you stepped into a Star Wars movie.
Yeah, it's incredible. It's huge, and they got so many things in there, and the photos come out incredible. So
I don't know who to ask, but I got something I want to show too.
Good. All right. Sorry,
It is
Mike.
long.
You can probably go ahead and
That's fine.
continue.
Okay, sorry, my monitor's fixed. So I don't know if you can see it very well, but originally I had this for my senior project, and it had a Atmega 128, kind of like the Arduino running free RTOS, and now that died, so I'm using a Raspberry Pi Zero to kind of upgrade it. So I've made kind of a custom board to go on the Pi Zero. It has a regulator. This is for an optical encoder, which is for distance measuring. And it goes on it's a 4-wheel drive RC car. And it measures the drive shaft. And then it has, for the motor controller, this is the motor controller. And I'm trying to do all of this on a Raspberry Pi. I wrote a driver. I was kind of curious to see if Pi Zero had good enough performance to read a quad-secure encoder and control the motor H-bridge. And it was working. I can show you, let's see. So this is my Raspberry Pi. I think you can see that. And I just wrote a driver. And then I have a SysFS interface. So I can tell it, I can see what the encoder reports for how much ticks it's gone. I can tell the motor to go forward or reverse. And then there's a PID loop that I was working on, and it was sort of working, but then the encoder broke. So now I have to fix that somehow. So that's kind of as far as I got. And I'll show you, let's see. So this is what the robot originally looked like when I did it in college. So it had a Atmel microcontroller, a GPS, a magnetometer, and then the encoder and motor controller, and a screen. That's a close up. This was quite a while, about 15 years ago. And this is the encoder I have. It's optical, and it's a disc with a bunch of ticks on it. And it was working pretty good, but now it broke, so I have to fix that. So yeah, that's about it. I know it's a work in progress.
Hey, come on, dude.
I'm busy doing something.
I'm not going to do this solo.
No. Yeah.
Cool, Mike.
So
Yeah.
Mike, one of the things that the Raspberry Pi doesn't do super well is high-speed digital I/O.
Yeah.
So I was
And-
just wondering, can you talk to me a little bit how you got that to work reliably?
Well, I don't know about reliably yet. So it was kind of working, and it was like 10% or less of utilization. So what I did, I wrote a driver and used interrupts on the optical encoder. And it seemed to work well enough. Yeah, I mean, I also used Diet Pi as the OS, which has less stuff than Raspbian on it. So, because Raspbian, sometimes it would slow down a little bit. Diet Pi didn't seem to have as much of that problem. And I still have to do more testing to see if it can keep up and if I can run other stuff with it. But using the kernel interrupts as well as I used register access of the GPIO, which is supposed to be faster than the built-in functions. It seemed to be fast enough, but I might have to end up using Arduino, a separate Arduino board for it, but so far it's worked.
You know, that's great. I'll probably ask you some more questions a little later about that. Thanks.
Yeah, sure.
Mike, you said that your encoder broke. Do you want to use a different encoder? Because those Oak Grisby encoders that I posted in the email, they are great. I mean, that's right for your card.
Okay, what is that on the message board? On the
Yes,
Google?
it is in the email chain.
Okay.
And it is Oak/Grisby, Oak/Grisby, and you can find them on eBay. They are about $20 a piece.
Okay.
And the reason why they are very good fit for your particular case is because they are like 100 pulses per rotation.
Okay. Yeah. That
Your
would be-
encoder seems to be much more than that, right?
It depends. That picture was about 256, I think. The problem is I need it really small because it's a small RC car. But I can, they still sell them, so I can order similar to what's on there. But yeah, I'd like to check out the one you're using.
They will need level conversion. They are 5 volts.
Okay.
And the Raspberry Pi is 3.3 volts. But rather than that, there is no problem.
Yeah, I put a resistor, a level shifter on the circuit board, which seemed to be working because the encoder I have has the same problem. So it's a resistor divider that shifts the 5-volt signal down to about 2 volts.
And also a different question. How do you feed your motor controller? It takes RC type PWM, right?
It takes one PWM signal and AV input, digital input. So it's like 1, 0 is forward and 0, 1 is backwards, and 0, 0 or 1, 1 is stop, I believe.
So
So-
it's not RC type, right?
No. Yeah. But it uses the PWM as the modulate to modulate the speed. Similar. Yeah. So yeah, I might use the Arduino for all this because that would be easier, and it would allow me to monitor the lithium battery, monitor the voltage on it, which would be nice to do. So I haven't really decided on doing that yet.
You may want to look at Teensy. This
Teensy?
is Arduino on steroids. Instead of 16 megahertz, it has like 72 megahertz
Oh wow.
rate. And
Okay.
it has very good ability to generate and read PWM and everything else. So
Cool.
Teensy.
Okay. Thanks.
Yeah, Mike, this Bob Allen. I would recommend the Tensy is a good idea, but the new Tensy, the 4.1 or the 4.0, runs at 600 megahertz, and it's really a nice little processor. I use it on some of my robots, and I've got 24,000 encoder counts per one revolution of the wheel, and I got 2 of them, and it handles it really, really well.
Wow. Okay. That's way more than I would have, but yeah, that would be good.
The 4.1 is a little expensive, right?
It's a little bit more, maybe $10 more. The 4.0 might be a good one for Mike. It's a little smaller. It still has the same capabilities. The downside is on the 4.0, there's a lot of I/O underneath, and some of the pins are hard to get to. Where on the 4.1, they spread them all out, so it's easier to get to all the I/O pins. But take a look at any of the Tensys, especially 3.5, 3.6, 3.4, or 4.0. Yeah,
Okay.
that might be a good option for you.
Cool.
I'm
Thanks.
kind of stuck with 3.2 and I like them very much. But one thing that I found kind of inconvenient with Teensy is that you have to use a desktop version of Arduino IDE, not the Windows 10, you know, kind of universal Windows application. So the old style Arduino IDE, and then there is a Teensy IDE edition on top of that. Just keep that in mind. But once you set it up, it's a wonderful platform.
Cool.
Yeah, and there's some really good instructions, Mike, on the Tensy website of how to download the Tensy drivers and stuff compatible for the Arduino IDE. I use the Visual Studio IDE for all my development, and that works on that as well. It's a little bit more powerful and gives you a little bit more opportunity to do some real programming with, but both of them work just fine. And Sergey was right, you do have to use the desktop, but you do have to download some stuff for it. But I've had no problems following the instructions. They work really well.
Okay. Cool. All right.
All right. Any more questions or advice? Well, I guess I'll wait for me, and we have Camp. Camp, you want to do your demo?
Sure, why not? Ready or not? Here we go. let's see, I got married 2 weeks ago.
Oh, congrats.
Yeah, I moved out of Southern California. I moved back home to Tallahassee, Florida. I asked my sweetheart here to marry me, and she said yes. So now I've got a robot called the Barbie Bot. It's got Barbie hairdress, manicure Barbie for my niece, and I wanted to use her as the flower girl. And Nance said, no way. And so that's when the Zoom Bot was born. That's a robot that I've put the computer on, and it basically has the Zoom. And that's what you're on now is the Zoom Bot. And so let me just share a few images from the wedding here. Share screen, share. And here you can see some images from the wedding. Yes, my bride came in on a Harley Davidson. That's Bo Davy. He played Here Comes the Bride on a Harley. And then once she got off the Harley, they played Wild Thing. So here you can see the Zoom Bot over here in the corner. We had about 40 people at the wedding, and there were about 60 people online with the Zoom. So it was quite a deal. Here's the Zoom Bot here. And here's a shot of our wedding cake. As you can see, there's a robot on a motorcycle. It's a Can-Am. It's actually a three-wheeled motorcycle. My wife is a biker chick. And so here's another shot of the Zoom Bot. And there's another shot of it. Here I am driving it around. There you go, some more images. There's the cake again. My niece made that cake, by the way. Marie's Cakes.
Cool. Wow.
The shot of the Zoom Bot there. All right, so let's do this. Let's see, bear with me. So screen right here. Okay, is my screen the screen that's on right now? I want to show my robot that's on the floor.
You're not sharing screen.
Okay, well.
We're still seeing it through the Zoom Bot.
Share screen, share. Okay, and let's see, stop share, you are screen sharing. So I got screen share off, and what do I need to do here? Do I need to go to the Zoom screen? Let me just exit all this stuff here.
You can open the app called Camera.
Okay, let me.
And then you can share the screen of the
Here's
camera.
my camera app. My camera app is okay. Yeah, I still got Mike on the screen here.
Yeah, so do I.
Yeah, I do too. What?
Is he pinned? Maybe they pinned his screen.
I clicked on speaker view and it popped out.
Yeah. Kemp, I'm watching you. You're the one who's on screen right now.
Okay.
Mike is.
Let's see.
Really?
Okay, speaker view. Okay. Anyway, so you guys can see me, right?
Yeah.
Okay, cool. Let's just try to get the angle on the camera right here. You see my Neato robot. It's actually not a vacuum cleaner. It's running Ross. And let me. Well, I got you on there. I'm going to go to chat here and share a RV SV. Let me share a GitHub first. This is the GitHub I get this from. Let's get to that. And chat. Okay, I'm sharing the, everyone. I'm sharing the SV Ross, Intro to Ross GitHub. This is what I'm running. Basically, I've got the, I've got inside in here a Raspberry Pi, and it's got the Ubiquity Robotics build on it with the BotVac package. Ralph Gnock with the Homebrew Club created that from Mike Ferguson's original Neato package. Let's see if I can get him to talk here. This is eSpeak. Could you hear that?
Yep.
Did it say yum yum?
He said, knock, knock. Oh, I blew it. Hang on a sec. Let's try this again.
Who's there?
Hang on. This will be worth it. There you go. Did you get it?
Got it.
Ed, knock, knock. Who's there? Art. Art who? R2D2. You're supposed to laugh. So part of the reason it's so sluggish, let me show you the Ubuntu screen here, is I'm running the video on the Ubuntu. I don't know if you can see this. I'll minimize the eSpeak, but if you can see this screen here, there's a PyCam in there also. I've tried to do this demo with the Zoom on the Zoom on the Ubuntu workstation, running the mapping and navigating, with the and that's way too sluggish. So I've got a PyCam here. It's the Raspberry Pi 3B Plus in the dirt bin, being powered with a phone bank. And so let's turn back around here with the Zoom bot. And I don't know if you can see that map well enough. I'll get close enough, but you can. And what I'm going to do is I'm actually going to close the video because that's what's slowing it down. Let's see. Kill that. Okay. There it goes. So I'm going to kill the video screen here, boom. And so here you can see the map of my house, right? Can you see that more or less? Right?
Yeah, it's
okay. And so here you see the robot. Okay. And what I'm going to do on RViz here, the ROS visualizer, is first thing you do is you drive around, you map the house. And again, I've put the GitHub there if you're interested in following up on it. And I'll give you my email too. So if you're interested, you can ask questions. But so here you can see the robot's image in the map. And I'm going to come up here and click the 2D nav goal and simply point, press, and drag. And the robot will autonomously navigate to that place. and the robot will autonomously navigate to that place. Let me see here. Oh, I got something that crashed, of course. Let me restart that.
You're using ROS1, I assume.
Yes.
And are you using the ROS navigation stack?
Yes, I'm using MoveBase.
MoveBase. That's what
Yeah,
it's.
the ROS navigation stack is MoveBase and AMCL.
Okay, right. Yeah, I just
Monte Carlo localization. Okay, let me relaunch the bot package. And I'm going to relaunch the navigation stack. And I'm using Ubuntu 16.04 and ROS Kinetic. I've tried to bring this into Melodic and haven't had much success with this. And the other day we had a really great presentation on ROS 2 from Mike Ferguson, and I'm excited about attempting to move this over to ROS 2. So we'll see where that goes. So I've relaunched my map. It loads in the map that I've saved. And there we've got the global cost map. You can see the light blue around here. And there's goes my local cost map. And so I'll attempt this again. I come up and click 2D nav goal and point, press, and drag at this location. And the robot will autonomously navigate there. It's my cat, Dart. There it is. You'll navigate around Dart. Thank you, Dart. Dart was a dynamic obstacle there. If you were watching the path planning lines, you'd have seen he should have gone through there, but Dart.
So is it detecting the live obstacle with the, is that, well, it's also with the LiDAR.
Yeah, Nito has a two-dimensional LiDAR.
Oh, it's Nito, right? Nito LiDAR?
Yeah, well, Nito as a product, as a commercial product, is a vacuum cleaner, okay?
Oh, right, yeah.
You press the button and it autonomously maps the room in parallel lines, and it uses the LiDAR to do that with. But this is a hack. This is not a vacuuming robot. This is a navigating robot. And so I put in the dirt bin the Raspberry Pi with the SV ROS, Intro to ROS package. The Nito has a micro USB socket that you can actually drive the wheels and read the LiDAR scans. And Mike Ferguson in 2010 created the Nito package to be able to map and navigate with. And Ralph Knox since then has updated it, getting the model, the URDF and Universal Robot Description Format, and he put it into launch files so it makes it easier. Don't be confused with being easy, okay? So here the robot has successfully navigated to the goal. And if you look at our map, the robot is now at the new location. And if you look at the navigation stack, it says goal reached. So we know the robot. And I've got another routine that I can set waypoints and have the robot just go from waypoint to waypoint. I can have him navigate around the room. So here I'll click 2D nav goal again and click here right in front of where I'm sitting. And the robot shall navigate back to the home base here.
If you were starting out and you wanted to make a ROS robot, would you recommend that the Nito platform still, or
yes.
Okay?
Yeah, I recommend this platform. I recommend a two-pronged strategy. And I'll put a link on the chat. There's a book called A Gentle Introduction to ROS that gives you the nuts and bolts. But you could spend all day with the nuts and bolts, right, and never have a functioning robot. So I would suggest a two-pronged strategy where you get the Gentle Introduction to ROS. It's available free online, or you can get a hard copy. and which again describes the nuts and bolts and the what am I trying to say? You know, the details on how it actually works. And then in really plain English as can be, and then get the bot back so you can actually get something running around, and you know, it makes the book, it makes the books, it makes sense with the book. There's something, and even the ROS tutorials are good. The Sim Turtle, okay, where you're learning publish and subscribe, and you publish these keyboard movements, and you're running the virtual turtle around on the screen, and then you can apply that to the bot vac, and all of a sudden you're running a physical robot around using the keyboard also, and then you know, you can move it into the autonomous navigation. What I was talking about is teleop twist.
Yeah.
Now the robots reach the goal again, but if I go to teleop twist, so you see the robot in the map here, and so I'll just make him go backwards and stop. I'll make him go forwards and stop. You know, turn left, turn right. And you can see the model of the robot doing the same thing on the screen. And so you go from, and let me put the link up there for a gentle introduction to ROS. You go from the simulated turtle, you know, to a physical robot, and you could still spend years, you know, learning all the details of ROS, but you've got something moving, you know, versus just learning the theory. A gentle.
I was going to ask you the TurtleBot itself, the hardware, TurtleBot 3. You recommend those? I mean, occasionally they're on eBay. It's an older platform, although they have a TurtleBot 4 now, or.
Well, the original, my goal is to get to something I call the smart table. In fact, the Zoom bot here, and I've got another one here, bear with me, Control V. Okay, there's the link to a gentle introduction to ROS. It's in the chat, but I'll back up here a bit. This is what I'm working towards, is you know, when you get, I call the one that you've just seen a Neato turtle, okay? But you see this guy here is I put the original TurtleBot superstructure on a Neato bot back. And I've had this working to some degree with the ultrasonics, so it doesn't navigate under the bed and under the couch. But the concept is something called a smart table, you know, where, you know, you eat on it, or, you know, whatever you want, and you send it back to the kitchen, and somebody deals with the dishes later, or maybe they can load it up in the kitchen, you know, and send it out. I think if you had a table that could reliably, you know, like a TV tray, that could reliably get from one place to another and back again, I think that's useful. I also think that the camera for telepresence is the low-hanging fruit. This is robotics, mobile robotics, in my view, is all about delivery, okay? It's all about delivery. And I think delivering the camera is the low-hanging fruit. You deliver the camera for communications, entertainment, and security, okay? Beyond that, you're just delivering stuff. And, you know, eventually we'll get to pick, move, and place, okay? But you gotta walk before you can run. And so, you know, to me, it's all about the base. You build this base that can reliably get from one place to another and back again, and eventually somebody will put an arm on it, okay? That's relatively well understood technology, the pick and place robot, but you need a base that can reliably get it to, you know, someplace. Questions?
I think your cat wants to get out.
Yeah, well, I got one more demo, okay?
I was just gonna say that.
It's like scratching.
I got one more
fight to
demo.
open the door.
I'll show you the robot room. So this is, that's Rocky there. Walter, there's the Zoom bot. Zoom bot's 21 years old now. That's Barbie bot's torso there. Let me give you one more demo. Now, the Homebrew Club, we've got something that we've been doing for almost 20 years now. It's called the TableBot Challenge. A TableBot is a robot that survives, lives, and plays on the table, or pays the price. And so the real end goal here is tabletop soccer. We've never really gotten there, but how you get there is in phases. And so what we've done for years is a three-phased approach, where phase one is to build a robot that goes from one end of the table to the other. And phase two is to build a robot that pushes a block off the edge of the table. And phase three is to have that robot push the block into a shoebox mounted at the end of the table. And we've done this for years. And we don't specify anything, the table, the robot, it's just run what you brung, okay? And so I built this robot recently. This one's I just call it the VTech robot. This is built on a VTech chassis. By the way, I've purchased 50 of these. So if anybody's interested, I'm willing to part with them for $10 each, okay? I'll put my email in here and you can send it. They sell for $12 at Robot Shop. They use, I thought these were micro servos. They're not micro servos. They took the controller out of them. So they're basically micro gear motors, okay? But they also sell this cool little 2-channel motor controller that works with RC PWM. So you're able to pulse the motors. 1 millisecond goes one direction, 2 milliseconds goes the other direction, 1.5, and it stops the same way you would a servo. I've always built my robots using servos, and I like it because you can do tabletop stuff and scale it up to larger robots using ESCs, electronic speed controllers. It's not the cheapest route, but time is the valuable thing, okay? And so I've got the VTech chassis I'm willing to sell for $10, and the controller, which Robot Shop does not sell. I haven't seen anybody sell these. I bought 50 of these too. I'm willing to part with them for $5 each. So this is, and I've got some $2 drop sensors I got from Amazon that Rohan helped me out with at the HPRC. What I need help with. I've been using Sharp sensors for years, and they're analog. And I read the description on this, and it's like a bad translation, but I never picked up on these are digital sensors. They're not analog, okay? They're 0 or 1. And so I went around the horn trying to make these things work. And Rohan finally, he looked up and he says, those are digital sensors, regardless. Without any further ado, I'm gonna switch on the VTech robot here and do the tabletop challenge, phase 1. Technically, that's phase 1 there. He's gone from one end of the table to the other. We don't define whether you go lengthwise or widthwise either. So anyways, there he is, the VTech robot. And like I said, I've got these available. This is a good little chassis to get started with. It doesn't include the controller board. I've got the chassis I'll sell for $10, and the controller I'll sell for $8 for shipping. It's a good little robot for kids to get started. Oh, I'll put a link for a homebrew build document I've made for this also. Bear with me.
Was that doing a random?
Yeah, it's just driving around, and basically when I detect something on the left, I back up and turn right. I detect something on the right, I back up and turn left. And eventually he'd get from one end of the room to the other. Again, the way the game is played is you'll put a block on the table, and the robot's eventually supposed to find the block and push it off the table. Incidentally, finding stuff is harder than avoiding stuff. Okay, and then finally you push the block into the shoebox, at which point you're in over your head and it's too late anyway. So, but we've had a lot of fun with it. It's not a contest, it's a show. And we've had a lot of fun with this show over the years. In fact, September 30, the Homebrew Club meets the last Wednesday of the month. I like to call it the Ultimate Wednesday. And this month is our challenge month, where the whole meeting is nothing but show and tell. So I want to encourage you guys to show up at the Homebrew Club Zoom meeting on September 30 and have something to demo, and we can all have some fun. So this is the build document for a VTech robot with basically bumpers on it, okay? This one I've outfitted with the drop sensors. And then I'll put my email address here too, if anybody's interested, or you know people that are interested that may want to buy one of these chassis. Send me an email.
By the way, if anyone didn't know, you can save the entire chat window by clicking the little ellipsis and selecting Save Chat.
I didn't know that.
Makes it easy to save all the links.
Very fine. That's it. Thank you very much.
Thank you, Cam. That was really good.
Indeed, thank you.
I want to make a Ross robot now. I've done only Ross in virtual space. But now,
Well, again,
oh, go ahead.
This BotVac package is a really good way to do it. To start off with, get a ratty old virus-infested Windows computer, format it with Ubuntu. For the BotVac package, I'd recommend 1604 Kinetic. And then with the folks at Ubiquity Robots have put together a really nice image for the Raspberry Pi. And I've done this demo for years with the computer Velcroed on the BotVac, but now you can put it on a Raspberry Pi and put it into the dirt bin. So it's really slick.
That's cool. Okay, we're running a bit late. I think Tim had a presentation. Tim, are you still there? We'll wrap up with Tim.
Yeah, I'm still here.
Okay, Tim, take it away.
Okay, what did I do to? All I see is you, so I don't see me on the screen, other than my little picture.
Oh,
is there something I need to push or something?
You want to share your screen?
No, not necessarily, just a camera.
Yeah, we can see you.
Can you see me?
Yeah.
Tim, when you speak in speaker's view, your image shows up.
Oh, okay. You see me okay?
Yeah.
Yeah, we see.
All right, I've been working with, I've been experimenting with some Adreno stuff with the Wave Shield and some Adreno 8x8 LED things from Adafruit, whatever, and came up with like a little cool idea for a costume type of thing, which also allowed me to distort my voice and change the pitch and everything. I just got the stuff where I can wear it. So basically what it consists of is, I don't know, can you see this?
Yep.
Okay, these are 8x8 displays. There's 3 here and 2 here. So this is for the mouth. This is for the eyes. And I'm got some circuitry there. I don't know if you can see that or not. That's all the circuitry for it there. It consists of huh?
We see it.
Hold on.
We do see it. Now I see it better.
Okay, it consists of an audio amplifier, an Adreno Uno with a wave shield in it, and it's been modified so it will pitch change my voice. And at the same time, the displays will blink simulated eyes, and the mouth will go to my voice. But it also will be distorted or pitch change. I can change anywhere from Darth Vader to Mickey Mouse. So this is electronics. The idea was I would make it so it's wearable. So if I'm wearing a morph suit, basically, you won't see where my eyes are because you see the things are above my eyes there and right across my mouth. So I don't know how much you can see here. Okay, let me turn the displays on here. Okay, hold on a second. All right, I don't know if you can see the eyes moving and stuff. Can you?
We see.
Right, Tim.
It's a little washed out, but
yeah. Hold on.
Try shutting the light off that's facing you.
Hold on.
Yeah, turn off some lights.
You look like Jason.
Oh, that's better. That's a whole lot better.
Hold on. Let me turn the inner lights on back here.
Watch your step.
So it's something I saw on. It's something I saw on Adafruit website. So basically, these are the eyes. They're just randomly looking around and the mouth goes to my voice. So if I wear this, I'll turn the amplifier on.
Yeah, you might want to turn the brightness down or put your finger.
Now you are the master.
Actually, the backlight often helps.
No, it was the it's overexposed, the problem.
Well, the idea is that it's going to wear a
Oh, there.
Can't understand you, but that's very nice, Tim.
Change the page to something a little higher.
Rule the galaxy, father and son. You look like a really creepy Ninja Turtle.
Yeah. I think if I was more like a road or something.
Tim, it's very hard to understand you.
Yeah, that's not quite the right.
I think that's the point.
Voice modification, but the conspiracy theorists are going to get a hold of this and they're going to run wild. Creatures from space.
This is awesome for Halloween.
Well, not necessarily Halloween. It'd be good for cosplay or anything else I could think of.
Still good for Halloween.
Well, yeah, like you could do that. Halloween wasn't the only thing I was thinking of, but again, it's sort of cool because it's all running off an Arduino. So, what do you guys think?
Excellent.
I like
Very
it.
cool.
Kind of had an idea
Cool.
like it a little while ago.
Like it, Tim.
Extra creepy in a good way.
Well, again, you could put it in a robot for its eyes and mouth and stuff. It could look like it's talking. The idea, these come in different colors. I don't necessarily have to have red. Or if you get one that's an RGB, you can change the colors at will. I haven't tried that yet. But again, I was just trying to do these are based on a couple of Adafruit's tutorials on running the displays and the wave shield, doing a voice pitch changer.
Use the eyes for the Raspberry Pi. Click on the little OLED display.
Yeah, but it's cool. It's cool. I'm gonna try the whole more suit on later to see how it looks.
If you don't want to use it for Halloween, I know someone who wants to borrow it.
Well, I mean, why? What do you want to do?
Well, in order to rob the bank, they have to understand you first.
Well, I'm sorry. That's not the intention of this thing, but it is a cool thing.
What?
Well, what?
I didn't hear that. So anyway, that's one of the things I've been tinkering with.
That's great, man. I love it. I absolutely love it. I think it's a great.
I have a little bit of bad news there. The company I work for right now, they lost a major contract. So basically, I think I got about another week's worth of work, and I'm going to get laid off for a while.
Oh, sorry, bud.
Yeah, well, I've just been working on some interesting stuff. I've been working on Artemis board. Been working on a feather board. Been working on a feather board's a board that's a little more powerful than an Arduino, but it has Bluetooth built into it. And then I got another chips I've been working on at home. It's basically a web server on a chip. You can actually call it up on the web page and actually command stuff with it through Wi-Fi.
That's cool.
So I've been experimenting with that and using it to control stuff. Some of the stuff I've been doing at work where they're making a new product and they need some electronics to make it go. So I've been working on, reading sensors and working on with smart servos from Lynx Motion, which are pretty cool because they're serial. Learned how to actually talk to it talk to it without using the through the SIR report directly. Was sort of cool. So that's just some stuff I've been working at work. To me, this time around, working at work was I got paid to play.
That's the best way.
Of course, I got to learn all sorts of cool stuff.
I still
Any
think that
questions?
mask has potential for Halloween.
Oh, definitely.
What, Camp? What do you want to do?
I was just saying, I think that mask has some real commercial potential for Halloween.
Well, I was thinking maybe turning it into a product or something. Some variations, you know, the mouth is green here, the eyes are red. I mean, what that make this yellow or whatever other color.
Halloween comes every year.
Yeah, but you can do it outside of Halloween. My idea was to be able to do it for cosplay, Star Wars stuff.
He's a hockey.
Yeah, you could have, if you can, you know, ask Walter if you could make a Jawa voice, then you got the red eyes already.
Yeah, I have a Jawa. I have a board with it.
Huh?
I do have a board with the Jawa sounds already in it that I pre-programmed for my costume.
Yeah, but I can make it so you have over 150 different Jawa things you could say. This the Wave Shield basically lets you store files on an SD card.
That's cool.
Put the mask out on a pumpkin and the speaker and do it remote. You know, which this Halloween would be a good thing. You know.
I mean, you could put these eyes in a speaker, in a skull, all sorts of different ideas. Doesn't necessarily do this. This was just something that I saw on the Adafruit tutorials on Halloween a year or so ago, a year or two ago. Decided I want to make my own version of it. I just finally was able to tinker one together with.
Did they use the Jason mask too?
Huh?
Did they use the Jason mask?
I think they do.
Yeah, well, I mean, I wanted to get a ski mask. Unfortunately, I ended up when I found it ended up be like the Jason mask, but it could be a different type of mask too. It's just what I was able to get a hold of.
Oh, that's perfect.
Nice.
All right. Can I just show something real quick? It's just a 1 minute.
8x8.
The 1 minute video.
8x8.
Oh, sure, of course.
All right.
Well, I think, yeah.
Let me show you something real quick here. All right. So this one, can you see it?
Ah, it's from your IG11, yeah.
Yeah, so this is, well, it's some of you have seen it. It's a 3D printed IG11 self-destruct bomb, you know.
Oh.
But I'm using the microbit with NeoPixels in there. So I just, you know, program in the MicroPython or whatever it is with the microbit.
Yeah.
So it's pretty cool to play with the NeoPixels in there. And then I did a few other things. I'll show you real quick.
Oh, your Jawa costume.
Yeah, so I got my Jawa costume, and that's the IG-11 head from The Mandalorian.
That's looking really nice now.
That was like 3 months ago. I stopped, you know, I took a break. I haven't done anything with it.
I don't remember if I saw it fully painted or it's nice.
Yeah, well, I completed the whole thing. It's big. It's like over 6 foot tall.
Right.
How come you're wearing your costume?
So there's some more NeoPixels. And the whole head is animated. All the different levels on it move. It's got some bearings in there and things like that. That's my 3D printed Baby Yoda.
Wow.
Is it hard to do those circular or twisting or whatever?
No, it's using bearings.
Bearings.
And some servos with 3D printed gears.
Oh, some servos. Like the servos like at the center or something?
Yeah, I have to look for the photos of how I assembled that thing. But yeah, next time maybe I'll do a little more on it, on how I did that thing. But
yeah, you might want to show us the inside. I don't know if I've seen the, you know, I don't even know how I would do a large rotational thing.
Yeah, it was through a group effort that we did this through a Facebook group. So It's came out really cool. I think only like 3 of us actually did it. I don't think anybody else was able to do it, but it's pretty cool.
Nice.
Anyways, so let me, how do I stop sharing this thing now?
Yeah, I'm trying to get my baby Yoda together.
Oh yeah, stop sharing, sorry. There you go. Oh yeah, Tim got his baby Yoda.
Very nice.
Unfortunately, I cracked one of the arm sockets here right across laterally. I don't know if I can fix it or I have to reprint another one. But the it's the hands. One Walter does 100%. This is at 70. So it's a little smaller.
Yeah.
You can see.
Nice.
Yeah, I've been having a little problem with my 3D printer. I can't get the damn bed leveled. I'm still working on it. Once I get it going, I'm going to do it again. Now that I got some time off, I might be able to finish the my Yoda character. I found some patterns online for the costume for it, for the both the size that Walter has and the size that I have. All I need is borrow a sewing machine from somebody.
Yeah, you got to get the clothes.
I bought one of those baby onesies at Target, so it fits mine perfect. So.
What is that? What is that? Oh, is that the suit that the baby suit he's wearing?
Yeah.
What size was that, Walter?
It's like for like a baby. I don't know what size.
Well, the
that
thing is, you printed it full size. I'm 70% smaller, which is probably more to the size of the one when they're holding it.
I know, but it's nice. You can actually buy a baby Yoda now. They have them all over the place. Target. And
well, the animatronic one's sort of cool, but again, I don't know if I'll still haven't made the market yet.
Very cool. And Thomas, got anything?
Tonight, no.
Not today? Oh, okay.
Tonight.
He usually does.
Next week. Our next meeting, I'll have something, I promise.
All right.
Yeah, I was gonna show something, but I think it's not. I'll wait because it'll be better. and we're kind of out of time. We sort of like to wrap up by 7:30 or so. People get their dinner. Alan, do you have any? Is there any other short things that people want to say or ask questions? Otherwise, we'll try to wrap up.
Oh, Thomas, I'm getting the truck back running.
Woo!
One in your driveway?
Talk to me offline about that.
I will.
Wait.
I've posted a link to the Homebrew Robotics Club mailing list. You guys join the Homebrew Robotics Club mailing list and come to our September meeting on September 30. It's all show and tell.
Cool. Sounds good.
Bring something.
I'll have something by then. I should.
Plenty of time.
All right.
All right. Anything else for Alan? Well, thanks for coming, everybody. And this is our first sort of all show and tell session. And next time we'll have a speaker. I'm not sure we didn't have a little business meeting about that, but we'll talk about that offline, and we'll look at the speaker schedule and find out who's doing it. But and we'll post that.
At some time, if you want, I could give a lecture on some of this Bluetooth stuff I've been playing around with. But rather interesting.
Oh yeah. Okay.
Because I can control a bunch of NeoPixel stuff with my phone.
Oh, that's cool. And it goes to a that web server thing.
No, this is a Featherboard. It's basically
that's the Featherboard with Bluetooth. With
Bluetooth. The web server thing's a different chip altogether. I got a little vehicle I'm working on. I'm working on my mini Mars rover right now.
Oh, nice.
I haven't got it done yet.
Yeah. So next time we'll have a speaker, and then so every other meeting will be like this. We're planning to do that, and then we won't have to find 1 hour talks as much because there's just not.
Well, show and tell's always fun. And it was nice to meet you, Camp.
Yeah, thanks, Cam.
Yeah, show and tell's the best.
Mm,
Got to have a deadline or nothing happens.
It's
yeah.
true. I got most of my stuff done when we had contests when we had in-person meetings, and I would always cram for the contest. Yeah.
Not only do I do my best work under pressure, I do all my work under pressure.
Yeah, that's cool.
Yeah, you can always set the next meeting as your deadline to show something.
Always a deadline.
Yeah, I missed it this time. I was on vacation.
All right, folks. Nice to meet you.
All
Yeah,
right.
good-
Yeah.
See you.
Great. Thank
See
you.
you next time.
Thanks, everybody. Have a good night.
Take care.
Okay.
Okay.
Take care, Walter.
See you later. Thank you.
Thanks, everybody.
Okay.